Hello, everybody. Thank you for coming here. Very exciting to talk about Redshift serverless for the very first time. So today, I'll talk a little bit about Redshift, about the evolution that brought us to serverless. And my colleague Nirja will do a deep dive into serverless and talk about the features, do a demo. And after that, we'll answer all your questions. But first, let's talk a little bit about the data and how the data changes our life, the way we play, the way we work, and how you're reinventing your business with data. In the modern world, only the most informed succeed. Those who have access to data make better decisions. They respond faster to unexpected, and they are uncovering new opportunities. In the modern world, analytic requirements are coming from all sides, from everywhere. And the amount of data we need to process increases from terabytes to petabytes. And sometimes we even see customers with exabytes of data. And while today the majority of the data is stored in the cloud, we and you still don't have a comprehensive solution that lets you analyze everything, that lets you work with all your data. Our customers are telling us that they want a reliable analytic service that can handle this data, that can handle changing workloads, and they need capability to analyze all their data. In the past, business leaders were using IT, were using administrators or specialists for all their business needs, and developers were using DBAs to manage warehouses for them. In the modern world, this paradigm doesn't work anymore. Everybody wants self-service, zero-touch services that they can use to work with data every day. They want to make this part of their daily routine. They want to get very fast to the insights that data gives them. Let's talk a little bit about Redshift. We launched Redshift in 2012 as the very first cloud data warehouse. And we continue to evolve it based on your demand, based on your needs, and based on the changing landscape. We added Spectrum to let you join the data in your data warehouse in S3-based data lake to give you access to all the unstructured data in your analytics. And we added concurrency scaling to make sure that you can, make sure Redshift can adapt to changing patterns of the workload for better performance. And we continued with Redshift Managed Storage, starting with RA3 instances to let you independently scale compute and storage to make sure you can only pay for compute you use or for storage you use. And then we follow with Aqua, Advanced Query Accelerator, to give you better performance, to improve performance of the query up to 10x. And then we added compilation as a service to make sure we can compile your query in the background for even better performance. And then we added federation to RDS and Aurora to make sure you can not only analyze your warehouse, but have access to your operational data. And then we added data sharing to make sure that you can share data within or between organizations without hassles of moving it or creating ETL pipelines. And then we added Redshift ML to make sure you you can build and exercise models right inside of the Redshift. Today, tens of thousands of customers are using Redshift. They are processing petabytes of data to get to the insights. Let's name some of them. Zynga is one of them. It's a very popular social game developer. And they're generating and processing up to 5 terabytes of data daily using Redshift. Magellan RX is another one. It's a healthcare provider. They work in automating pharmacy, and it's a pretty complicated process. They chose Redshift to build their data story, and by using Redshift, they were able to lower their cost to 20%. They're also leveraging email to predict prices of drugs and to analyze trend. Another example is NASDAQ. You all know NASDAQ, and NASDAQ depends on data probably more than any other companies. They are storing some of the data in the data warehouse and some of the data in S3. They are relying on ability to join the data from data lake and data warehouse to let their analytics do real-time analysis. So talking about Redshift, we can say that Redshift lets you analyze all your data and get to performance at any scale with low and predictable costs. Based on your feedback and request, we are focusing on the following 3 areas. First, we were always focused on the performance and continue to be so, especially from out-of-the-box performance. Performances over complex analytical workloads is especially important today. Second is ability to analyze all your data. Right now, data comes from everywhere in all shapes or forms, and you want to have ability to analyze not just your data warehouse. You want to analyze click streams, you want to analyze logs, you want to analyze transactional data, semi-structure, and many, many more. And last but not least, our customers are telling us that they need easy analytics for everyone. They don't want to rely on IT. They want to be able to do it themselves, every one of them. So let's talk a little bit about each of these areas. Starting with performance. We all know that the shape of the workload changes all the time. And Redshift wants to deliver consistent performance in the face of these changes. We have talked about some of the features. We've talked about Redshift Managed Storage, for example, that would let you separate charges for compute and storage. Let's talk a little bit more. Let's talk about materialized views, for example. We have lots of customers who have tables with thousands of columns and billions of rows. An ability to pre-compute materialized views significantly improves the performance of queries for them. And what is great that for all these features that would deliver performance in Redshift, you don't have to pay extra. There is no upfront fees. And if you're using reserved instances, you can save up to 70%. What about analyzing all your data? We see that there are 4 trends in the modern data strategy. Number 1 is a data lake. Customers now want to not just store their data inside of the data warehouse. They want to store data, especially semi-structured data, in the data lakes they own, and they need a service that has access to this data. They need a service that would understand all the open source formats and be able to join them with the data warehouse. Second, customers are looking for ability to share data within organization, across organization. Customers want to monetize their data as well. That's why the feature we recently announced, integration between Redshift and AWS Data Exchange, is very important. This feature will let you both consume data from your partners, but also monetize your own data. Number 3 is ability to get outside of your data warehouse and analyze the data in your daily operational processes. That's where federated access to operational data is very important. And last is ML. There are more and more people want to use ML as a part of their analytics, and that's where it is important for us to have features like Redshift ML that would give you ability not to step outside of your outside of this service to do ML operation. Oops, sorry. So today, Redshift gives you all this ability. You can control Redshift very easily. You can choose instances. You can scale your clusters. You can use data sharing. There are lots of features Redshift has, but you need to be a specialist there. And you need to understand what you're doing. And while managing data warehouse, it's a core competency of IT professionals. You sometimes don't want to use them. You want both ability to work with data without worrying about provisioning, configuring it. You also don't want to worry about scaling the data warehouse yourself. You want this just to happen. So that's the big ask from our customers. What they want the data warehouse that on one end would retain all the features of enterprise data warehouse, will have rich SQL capability and high performance, but the warehouse that will manage itself without your help. And that's where Redshift Serverless comes to the picture. Redshift Serverless will let you exercise all the features of Redshift without worrying about managing it. First, Redshift Serverless has a much simplified user experience where you don't need to provision anything. You can start in seconds, land directly in Query Editor, and just start querying. Redshift Serverless intelligently manages capacity for you. You don't need to worry about sizing or scaling your data warehouse. Redshift Serverless doesn't take away any of the functionality you're currently using in Redshift, all the rich SQL, ability to do federation, data sharing with provisioned Redshift, all is there. And the last, which is very cool, you only will pay for the time you use. If you don't use your data warehouse, you pay nothing. Well, now I will ask my colleague Nirja to continue and do a deeper dive into Redshift Serverless. Thank you.
Thanks, Jan. So I'm going to walk through the key capabilities of Redshift Serverless. So we'll go through some of the 4 key tenets that Jan just highlighted. We'll walk through each of them and try to explain what exactly those are. So the first part is one of the first key tenets is simpler. the experience both on the queries as well as on the management side. So getting started with serverless is very easy. So all you need to do is go to Redshift console. We have a new option called Try Redshift Serverless. Right now is in preview. So you would click on it, and it would enable the serverless endpoint for your AWS account. And you can review the default configuration. If you want to customize anything, you can do that. And then that's it, right? And you would go to the Redshift query editor, which is an out-of-box query experience that comes with Redshift, which will allow you to author queries and work with the data warehouse. So just quick steps there. And then you will be able to leverage all the data for analysis. So all the good features of the query editor, like for example, you will be able to create your own databases, schemas, tables. And Redshift supports diverse data formats, CSV, JSON, different data formats, so you can load data from there. And you can also browse the data from S3 directly and load the data. So much simpler experience in terms of data ingestion and the queries. And the seamless data lake integration capabilities of Redshift are applicable in Redshift serverless. So you will be able to query the open formats such as Parquet directly from the S3 data lake, and you can also query the operational databases like Amazon Aurora, RDS, Postgres SQL database, MySQL. So that operational databases you can directly query from Redshift serverless as well. So the mechanism is really you create a metadata reference, and that's it. In the query editor, you will be able to browse the operational databases catalogs as well as the AWS Glue catalog, and you can start doing queries. So the idea is Redshift as such has pretty rich SQL functionality and nice integration with the data lake and the operational databases and the rest of AWS ecosystem. That entire functionality, the analytics richness, comes to Redshift serverless as well. We are not compromising on any of that. The second tenet is intelligent and dynamic compute management, right? So the idea is Redshift serverless would automatically provision resources for you. It would automatically manage the resources for you by right-sizing the compute based on your workload demands. So Jan talked about a lot of innovations we have been doing in the last few years. So we are certainly leveraging all of it and adding more in order to enable the intelligent and dynamic compute management. So I think a particular key component there is the top box there, which is a deep understanding of the workload patterns, right? So we continuously monitor the queries, try to understand what the workload is, and apply a sophisticated machine learning algorithms to really develop deep understanding of the user workloads. And once you have that understanding, a lot of things can be simplified and automated. So all those auto things that are there in terms of their set of core services, like automatic workload management, looking at the queries and make sure you allocate right amount of resources. If it is a small query, small amount of resources. Big query, bigger amount of resources. So making the right resource decisions. Another one is automatic scaling. When should the system scale, and what should it scale to? So that's an important decision to make. So, and again, a deep understanding of the workloads is very critical there. And when we do the scaling, the idea is we maintain the high performance, but we also want to optimize the costs, right? So that is a critical area for serverless. And other things, like when should you do the version updates? What is the right time to do the upgrades to the next versions? So again, you need understanding of the workloads. So, and the pay-per-use part is a crux of serverless, which is when there are no workloads, no queries happening, shutting down the compute resources and bringing them up when the queries start arriving, which enables you to pay only for the compute capacity that you have used. So a lot of innovation, leveraging what we already have and built more, is around the intelligent and dynamic compute management tenet. So briefly on the billing, just to get some idea, in Redshift serverless, you pay for the compute and storage independently. On the compute side, we are introducing a new abstract normalized compute unit called Redshift Processing Unit, RPU, and you would pay for the duration of the workloads on a per second basis. So that is the billing on the compute side. And you would pay for the base data warehouse, any scaling that the system would do as you have more and more workloads coming in, so that the capacity is billed as RPU hours. And one important thing we have done is the data lake queries. So not just the data that is loaded into the data warehouse, but the data that you are accessing from S3 data lake. Any queries you do to the data lake, they're also metered as RPU hours. So the entire billing in terms of compute is unified and simplified. So things like concurrency, scaling, spectrum, these charges do not apply. And we didn't explicitly highlight here, but there are a lot of optimizations that Redshift does in order to continuously improve the performance. And also security features, like pretty robust security feature set that we have, they're all included as part of Redshift Serverless. On the storage side, Redshift uses Redshift Managed Storage, which is pretty similar to what you get with the RA3 instance types. And on the storage, you would pay for the storage of your data. It's same as the Redshift Managed Storage pricing. And any snapshots that you have created, you would pay for that. And one important thing that we have added in serverless is the notion of a recovery point. So for the last 24 hours, you have ability to go back in time, essentially. At a 30-minute granularity, you can restore your data warehouse to a specific point in time at that granularity. So that capability is referred as recovery points. So that is something we are introducing newly in serverless. So a little bit more on the pay for use, right? So pay for the compute capacity only for the workload duration. So what we mean by that is, this is just a quick example here. There is a 15-minute time duration. And in this particular scenario, you have 3 queries. This is a super simplified version. In reality, we are talking about thousands of queries. But in the first 3 minutes, you got 3 queries, Q1, Q2, Q3. And a little bit later, you got another query. Little bit later, another query. But overall, out of the 15-minute duration, you ran the workload really for 5 minutes and 30 seconds. So with Redshift Serverless, you are just paying for 5 minutes and 30 seconds, right? So that is when you actually ran the queries. So that's what you would pay. So there are no hidden charges in terms of the idleness on the compute capacity. Actually, another point that I think worth highlighting is in terms of the pricing model, as you can see here, we optimize for concurrency. So what that means is the first 3 queries came in the first 3 minutes. So you are paying for 3-minute compute capacity. You might get 3,000 queries in that 3 minutes, but you would still pay for that 3-minute. So we optimize the pricing for concurrency because a lot of workloads that come onto Redshift are things like dashboarding applications, data exploration, ad hoc queries. So these are coming from users, analysts, data scientists, different types of users, and they all have concurrency associated with it. So it's not a per query pricing, it's optimized for concurrent workloads. So by default, Redshift Serverless automates everything, and our expectation is that 90% of the use cases or even more, you should be able to just rely on the auto capabilities of Redshift and let it scale up, scale down, and take care of the resource management. There are additional use cases in which customers do want that extra control, either for performance, from a cost management perspective. So there are a couple of optional controls that we are adding. One is base capacity, which you can specify as RPUs, Redshift Processing Units. So if you want, by default, it is auto, means Redshift takes the decision. But if you want to control the base RPU capacity, which is the base data warehouse size, you can set that up. And another aspect is on the maximum, which is like a usage limit, cost control. So the base capacity is something you can set based on your workload performance requirements. So if you have an ETL job that takes 2 hours to run automatically, but you need it to be done very, very quickly, So you can go and adjust the base capacity to the max and finish that task much more faster. So that's the usefulness of the base capacity, improving the performance, or based on your performance requirements, you can choose that. The usage limit, on the other hand, serves like a cost control to keep your costs predictable. So you can set up like daily, weekly, and monthly limits, saying, I want to use 1,000 RPU hours in a given day. Beyond that, I don't want to spend any more capacity on Redshift serverless. So you can set up cost controls with respect to controlling the cost with Redshift serverless. And then you can define actions, whether I want to block user queries, whether I want to just log and proceed. You can have different options in terms of what exactly you want to do when the threshold is hit. The important thing, I think, which we treat it as a core design element, is you should not need to change any SQL analytics, business intelligence applications in order to use serverless. So the idea is, if you're already a Redshift customer and you do have clusters with data in them, you can take a snapshot, you can restore into serverless, you change your SQL application to point to the serverless endpoint, and that's it. Everything should work as is. And the reason is because, again, the serverless brings all the SQL functionality of Redshift, so everything should work as is. The one area where you will need to make some changes is on the management side, because Redshift serverless has a much more simplified SDK, because there is no cluster management involved. It's pretty simple. So any management scripts that you have written, they need to be moved to the Redshift SDK. But the core applications, the SQL applications, user-facing applications, they continue to run as is. In the data lake queries, we have made the data lake queries a lot more native in Redshift serverless from an architecture point of view. So from your point of view, from a customer point of view, what really matters is whether I'm querying the data that is loaded into the data warehouse, or whether I'm querying the data in open formats in S3 data lake, everything is uniform. Everything is treated same, everything is metered same, everything is built same. So from an architecture point of view, we simplified things, which translates as a much more simplified pricing from a customer point of view. So data sharing works as is in serverless. So data sharing, for those of you who are not familiar with it, data sharing allows you to securely and easily share live data across Redshift clusters. This could be in same account, they could be in different accounts, and we also recently integrated with AWS Data Exchange, where you can take data from Redshift and license it, or consume data from a third party into Redshift directly. So all these data sharing capabilities directly apply in Redshift serverless. As we illustrated in this diagram here, so what this is saying is, I have a data science use case, which is a lot more ad hoc type of use case. Marketing, same, a little bit more ad hoc data exploration type of use case. Both those things make sense to run as serverless, but I do have more predictable type of workloads like finance, sales reporting. Those things I'm running as Redshift provisioned clusters, and I want to be able to share data between them. So the mechanism of data sharing is exactly same, and you will be able to kind of seamlessly share data back and forth between the provisioned clusters and serverless endpoints. So I think it's worth mentioning that we are treating the serverless offering as a complementary offering to the provisioned clusters, right? So for certain types of workloads. So what are those workloads, right? So I can highlight probably few examples. There are a lot of examples, but we will highlight few. The first one is for serverless. We are classifying it as easy analytics, where I need to be able to get started easily. I don't want to think about infrastructure, or I don't know how to think about infrastructure when I'm just getting started. So how can I do this fast? So that's where serverless makes things simple. So you don't need to create and manage clusters. You don't have to think about, okay, which instance type I should choose, or how many nodes I have to choose. So that whole thinking goes away when you're trying to get the work done fast. So the simple use cases for that would be like development test environments where you're trying to get started. And another very, very common use case we hear is more ad hoc but self-service analytics. So a common pattern to think about is we have, let's say you have a Redshift cluster in which you are curating your data, getting data from all sorts of sources, you're curating the data, and then you have some users and who want to come and consume the data. So the pattern can be from the central cluster, you are simply sharing the data live, and those users, whoever want to consume the data, they will consume the data via the data sharing, and they can consume it via the serverless endpoint. So on the data side, data sharing simplifies things. On the compute side, serverless simplifies things. Together, they bring agility, right, in terms of being able to handle different workloads. Another use case, these are like a set of use cases, is just the type of workloads. A very common use case for serverless is variable workload. I don't know how much capacity do I need, or the capacity that I need keeps changing throughout the day. Maybe in the morning I need little bit, and after that there is some idle time. Around 11 o'clock it picks up, at 2 o'clock it goes even more. So you don't know, things change very dynamically, and it's hard to manually scaling up, scaling down, it just gets complicated. So the variable workloads is kind of the template use case for serverless. And the beauty is you only pay for use. So even though there are idle durations in between, you don't have to think about it because you are charged based on what exactly you ran, not for how long the capacity was just going to be there. Another use case is periodic workloads. So every 1 hour, I have some data coming in, and I have to process the data, and that run might take 10 minutes, right? And the next hour comes, again, I have some more incremental data that I need to process. So you know the pattern, but it's periodic. So you need the resources to kind of be provisioned automatically, do the work, come down. So that whole thing need to be automatic. So the periodic workloads is a very common pattern for serverless. Another one is steady state with spikes. So you know some activity is going to be there, some idea you have on steady state, but there are always, things are always dynamic. You can never predict this is exactly what I'm going to get. So you have some steady state, but there are unexpected spikes in which serverless, it can take care of provisioning resources, it can maintain the consistent performance, it can scale it up, scale it down, and take care of the capacity variations. So with that, I'm going to just walk through a very quick demo of serverless getting started. So the demo scenario is simpler in the sense like it is applicable across multiple domains. Basically, let's say I'm a data analyst in a large apparel company, and we are tasked with to come up with a holiday promotion to boost the sales. So that's really, so our task is that. And the data sources, we have historical sales information in S3 data lake. The current year's, recent year's information is in the data warehouse, which is what we want to put in Redshift. And the operational database, which is Aurora serverless, it has information on the real-time sales orders and inventory. So those are my data sources. And I also have an extra requirement, which is I need to provide some of these sales quantities to a vendor that we work with, or many vendors that we work with, and we want to share this data live to those vendors so they can make decisions on the inventory management. This is a recorded demo. So the flow is really, as I mentioned, you come to Redshift console, you can say, try Redshift serverless preview, which is the new feature, and everything is defaulted, so you don't need to do anything. By default, it integrates with IAM and the user credentials flow, so there is nothing to do there, but if you want to customize settings, you can customize it, like networking, security. In serverless, data is encrypted by default, with AWS managed keys. If you want to change the encryption key, you can do that. Audit logging. So there are some customizations you can do if you would like. And from a security point of view, it's the same kind of robust security that you would get with Redshift. So in this case, we are accessing some S3 data. So there is IAM role configuring. So this is configuring the serverless endpoint for the account. This is a one-time action. So you would start that. Then you land in serverless dashboard and start the queries. That's pretty much it. And the query editor, many of you probably might be familiar, is our web interface that comes out of box with Redshift, allows you to do queries. From the query editor, we are connecting to the serverless database, and you can start doing queries directly. And the query editor comes with some sample data sets, like benchmarking data sets like TPC-DS, TPC-H, and a few other data sets, so that you can kind of kickstart the analytics much more quickly, like if you are a novice. And you can also load the data from your own data sources. So in this demo scenario, the historical sales is in S3. We have the data for 2017, 2018, and this data is in Parquet. This is the S3. So we are looking at the S3 buckets. And the operational database is Aurora. So we have the most recent sales and the inventory information there. So we are in Aurora Serverless Editor, and we are quickly checking to make sure we have the right data here. So with Redshift, as we mentioned, with the data lake integration, you can access all this data as part of the Redshift query editor. So the query editor lets you browse the local data within the data warehouse, but also the data that is there in the RDS, Aurora Postgres database, and also the data that is there in S3, data lake, the open formats, Parquet data. So we can start doing by a couple of queries. I'm querying the local Redshift data just to look at what the data is looking like. I can visualize it as a chart in Query Editor, and there are many nice features of Query Editor. And similarly, I can look at the data from Aurora. So note we are doing all this in Redshift. So this is doing federated query to Aurora and bringing the data back in. Similarly, I can query the data that is there in S3. And you can browse the entire catalog as part of the query editor experience as well. So in my scenario, I need to combine all this data. So I'm creating a view from my local data warehouse data, S3 data, Aurora data. And we also have some web sales information. So we are combining with the web sales. But the bottom line is I have all of that in a view. So that's my data source that I'm working with. Now we can start analyzing our sales. So I see that there is some decline in the last couple of months, October, November. So I want to start investigation on what is the reason for this decline by looking at different categories of our business. So very quick queries with categories would tell me that I have some decline both on the men's category and the women's category. So normal SQL, right? So all the standard Redshift SQL functionality applies, and we are trying to kind of analyze and see what is the right promotion to launch. So for one of the nice things in Query Editor is data loading is very, very easy. So in this case, we have some previous year promotion data set. So which is there in S3, it was curated by the marketing team from the last year data. And then we are trying to bring it into the Redshift serverless. So this is a very straightforward process. What we need to do is come to the query editor, and you can browse the S3 data. In this case, we are picking the promotions. Pick the data set, and then you can specify where exactly you want to load, right? So what is the target schema? What is your target table? You can specify, you can bring that in. So essentially, we are getting the last few years promotion information. Now I'm in QuickSight just to make things simple in terms of visualization. So we are trying to dive deep into see, okay, which women's categories, there is a subcategory in women's that is causing this decline. So we are trying to analyze that. And there is a category, I think the dresses category is showing the decline. So there is an insight there. Similar analysis you can do on the men's category, and there is again a subcategory which is showing the decline. So as an analyst, basically, I'm looking at some of this information like promotion. Okay, which promotion has been effective? The 20% promotion is the most effective. So I can recommend that, okay, this makes sense to launch this promotion for these categories that are showing the decline. So the point is, analysts like this and many data scientists, developers, they are doing queries all the time, and all these workloads create the varying and unpredictable nature of demand on the data warehouse. And if you'll see this diagram here for the capacity, Redshift is automatically scaling things up and down based on the requirements. And this is a little bit of a zoomed out graph over a particular duration. As you can see, blue is queries, orange is the capacity, and as the capacity essentially aligns with the query demand. And when there is no workload, there is no capacity and everything is idle. We don't need to pay for it. And the couple of settings we talked about, the base and the cost controls, you can adjust them optionally. We don't expect you to use this all the time. Serverless should work out of the box. But if you want to control things from a cost control perspective, you can set up usage limits, daily limits, weekly limits, etc. The final use case is data sharing. So I am sharing the data from my serverless cluster to my vendor. So provision clusters can share data to serverless and vice versa. So you have all the data sharing functionality for serverless. So in this case, we are creating a view for the vendor just with the sales quantity. No dollar amount, but the sales quantity. So we created a view, and we are sharing the data live with the vendor. So the way you do it is you create a data share. All this, you can do it in the console as well in a UI. But from a SQL perspective, you create a data share, you add the view that you want to share with your vendor, and you specify which account that I want to share this data with. The account there is the vendor account. So you're sharing live using the Redshift cross-account data sharing capabilities. And the vendor would come in, and they can look at the data share. They create a database reference to the data share, and then they can start doing the queries. So we just do it in seconds, right? So there is no data movement, data replication happening. Data is shared live from my serverless cluster to this vendor who is able to immediately create a database reference and start doing queries. So the data sharing in conjunction with serverless would simplify things both on the compute and data side and bring the agility in terms of analytics across the organization. Hopefully that's helpful. With that, I will invite Jan back to wrap up and bring us home.
Thank you, Nirja. Looks like a cool demo. So to summarize what we've said, we introduced a new option for you in your Redshift usage. It's in a preview mode now, but it's open, so feel free to start using it. I will answer your questions right now. If you want to try serverless, here is the link. And if you wanted to learn more about this, please look at these web pages and feel free to ask me questions. Thank you. Cold start time should be around 10 seconds. And obviously warm up.
So if I have an existing cluster, say for example a EC2 8x large, and I wanted to move to serverless, should I be expecting more cost and better performance?
Good question. It's very difficult to comment on the cost without understanding the pattern of your workload. Generally speaking, if you have a well-sized and highly utilized cluster, the provision model is better. If you have less predictable workload, if you're using your cluster less than 60% of the time, serverless would be a better option. So, I mean, try it. That's why we have a preview. We wanted to listen.
What is the compute capacity of 1 RPU?
Compute capacity of RPU maps to 2 gigabytes of operational memory and associated CPU. We decided to shape mostly, I'm sorry, on operational memory, just because that feels like an easier dimension for customers to understand.
And I think just to add, the way to think about it, I mean, as Jan mentioned, is the workload, right? I wouldn't do like capacity to capacity mapping. It's more about, okay, is there idleness in the cluster? Do I expect variability? Do I benefit from auto scaling? So I think those are some of the considerations when you're thinking about serverless. Yeah.
Your ability to read a data lake, does that understand a blue catalog or link information governed tables, or is that just reading files?
It is Glue catalog. Yeah. The question is the data lake integration, does it integrate with AWS Glue catalog? The answer is yes. Yeah.
Yes.
Possibly similar question for me. I usually use my data lake data by using the Athena in Glue. So what is the main difference from using the serverless Redshift? What's the memory deployment?
Good question. The main Athena use case, it's at hot query, kind of it's still starting to query with Athena, would be faster. We are bringing Redshift usage pattern to closer to Athena as well, because lots of customers like that. But Redshift's still a data warehouse, first of all. Any more questions?
I guess along the same lines, what's the difference between Spectrum and data lake queries then?
So Spectrum is the functionality in Redshift, right? We initially built Spectrum as a separate service to query data lake. Lots of customers like Spectrum. What they don't like, that they need to pay for Spectrum separately. So we are just bringing the Spectrum functionality into Redshift and introducing simpler pricing model that has better cost control.
The Spectrum continues to exist in conjunction with the provision clusters, right? So that is the means to get to the data lake in the provision clusters. In the serverless, we are trying to take it to the next level by simplifying this pricing aspect where you don't charge anymore for the on a per terabyte scanned basis, but everything is rolled into this unified pricing model. So functionally, it is exactly same. The way you do Spectrum queries, it is exactly same. As I mentioned, like the architecture simplifications shows up as the billing aspect in the serverless.
So the performance will be similar then? Spectrum and this?
You should expect similar performance.
Yes.
Yeah.
So your question, the
Question is performance of the queries. Yeah, go ahead.
So there are two modes in serverless. One is fully automatic mode. And in full automatic mode, we will scale to your queries to achieve the best price performance the way we see that. If you can change the base compute, that way you can regulate kind of, you will give us a better input whether you want to, you want lower cost or you want maximum performance.
So maybe I think just to give a specific example, right? You ran a query, and we used 32 RPUs to execute that query. It's a 1-hour query. So for the 32 RPU capacity is used for 1 hour So that's what you would pay for. So you're essentially paying for the capacity hours. If Redshift scales from 32 to 256 because you have very heavy workload coming in, for that duration, you would pay for whatever is the capacity that is applicable at that time. The best, first of all, from a cost predictability perspective, your control in serverless is that max limit that I mentioned. You can say, I am spending some X dollars, you can translate that into RPU hours. RPU is the published pricing for serverless, so you can check the Redshift pricing page, and you can just map it and see this is the RPU hours that I want to spend. I don't want my spend to change at all. So I literally take my existing spend and translate into RPU hours and specify that as my cost control. So that's the way to put upper threshold. The next part is how are those RPU hours actually being utilized? So for that to be very deterministic, analytic workloads are extremely diverse, right? So there are small queries, big jobs, small jobs. Your environment has its own uniqueness. So whether you are getting the correct performance or not, the best way to do that is to try it out. But while trying, you can set this cost control so that you can be confident it is not exceeding your current limit. So, can you repeat it?
Yeah, like in our case, it's very steep based on the cluster. So we have like single users in query on a cluster, and then we have anyone from the business who like is actually using our Tableau dashboard or Looker dashboard, that user, like if individual users just explore our cluster, that's where
Yeah. So the mechanism to do that right now with what we launched as preview is serverless endpoint there is one serverless endpoint for AWS account. So your cost control that we talked about is at account level. So if you want to segregate the workloads and apply a different cost control for each, you will need to have it as a separate serverless endpoint in a different account. So that's kind of the current, what we have in the preview.
So we're trying to, we have a model.
Question is the system linear, right? Yeah, so Redshift main value proposition, irrespective of serverless, is the best price performance and linear price performance. So that is where it excels at, and those capabilities are applicable in serverless. So what we try to do is essentially give the best performance for more or less the same cost. Right, so rather than executing your job for 3 hours by using lower RPUs, we want to finish that task fast by doubling the RPUs. So that is the intent. You are getting the best performance, but you are not paying more. So the question is, are the distribution keys applicable in serverless, right? So the distribution keys are applicable in serverless. We don't expect that you have to think about it and you set it. That's where the automatic optimizations would come in, where we understand the workloads and we determine what are the right distribution and sort keys, and we adjust the data layout. But if you want to customize it and set it explicitly for whatever reason, you should be able to. The data side is not significantly changing, right? So think of serverless as the compute simplification. That's the scaling aspects and those aspects, yeah. So the question is, what is your default RPU setting? And how do you scale, right? So the default is, we have like two defaults. If you select nothing, the system starts, when you enable serverless and create a serverless endpoint, the default would start with 128 RPUs. That is the default. You can, however, choose when you get started saying, I'm just exploring it. I want to do this with like a starter configuration. That would start you with a 32 RPU setting. But if you do nothing, it starts in 128 RPU. And then from there, our recommendation will be you stay with auto and see how your workloads are performing, right? We don't want you to think about like immediately as soon as you start with working with serverless, how do I customize base capacity? What should I set it to? Like, how does this work? I mean, the idea is you shouldn't need to think. So the recommendation is basically go with the default, and you can observe the monitoring. So we have a variety of system tables as well as CloudWatch metrics. So you can understand, okay, it seems like on an average I'm using this many RPUs. So this might be my steady state, right? At that point, if you want, you can come and change the base setting. So the setting of the base and the changing of the base configurations, if you are interested in changing that is something you can adjust in the system. So scaling has two parts. The scaling as you have more and more queries, right? So depending on the type of the query, the nature of the query, we assign compute. So that is completely seamless, right? So you don't even have to think about it. And it will continue to maintain the consistent performance. But if for whatever reason you decide to change the base data warehouse capacity explicitly, the mechanism might introduce some additional delays when you are doing the actual scaling for a temporary period of time. And then it will get back to the normal state. Yeah. Yeah, so your question is when we are setting sort keys, distribution keys, how are they helping in the context of serverless because compute is dynamic? So I think that part is already taken care of when we introduced managed storage, right? So when we have RA3 and managed storage, we already separated compute and storage. So the distribution keys, sort keys that you set, they are operating on the storage layer, managed storage, for which the caches are in the local cluster, but the actual source of truth is in S3. So the way we manage our data distribution, sorting, it is on the data layer. It has nothing to do with compute. So serverless does not necessarily impact the dynamic nature of serverless compute instances. It does not impact it. It tries to leverage it, but it's not, there are separate layers. That's probably the simplest way to answer. Yeah, that's not an area, the data partitioning and how it is sorted, that is a separate thing than how the compute instances are coming up and going, mainly because of the storage compute separation. don't know if you want to add anything on that.
Yeah. I'm sorry, could you repeat the question?
Oh, which region?
Which regions? It's US East 1,
We have it in 6 regions.
6 regions.
Which region are you in? Maybe that's easy.
I don't think it's in Canada. It is in
It is
US
in
East.
US East 1.
It is in US East 1. In all the major regions, basically, the largest regions, the 6 largest regions.
One last question. So, does this significantly affect how to query caches in like the provision one? Like sometimes like you run the query, you get really quick results because all the results are cached. But in serverless,
The same.
It's the same.
It's the same.
So I think think of all the SQL features, performance optimization. So what you asked is result caching is a performance feature. So all the SQL features, performance features, everything is same. That's intentional, right? We are trying to maintain the SQL and the performance. The area that we are trying to simplify is really on the compute side of things. So that's the kind of way to think about it.
Okay, thank you. Yeah,
Thank
if
you.
you have more